let's go ahead and jumpstart our next section. And in just a little bit, we'll take a break and wrap it up. So if you have your graphing calculators nearby, you can go ahead and boot them up, because we're going to be doing some stuff with them. I will let you know in advance that I probably should have done some additional editing, and you'll see what I mean once we get to like the middle chunk of this note packet. But yeah, from here on out, the rest of the class is going to be devoted to working with our graphing calculator. So cool stuff coming up. This is kind of a mashup between graphing calculator skills presented in section 1 of chapter 1, as well as section 2. So there's a little bit more than just graphing calculator stuff in section 2, which we'll get to next week. So I kind of broke section 2 up into a part A and a part B. But the very first thing that we're going to do is learn how to have the graphing calculator sketch a graph for us. All right, and we're going to be using this equation to help illustrate all these steps. And I really wish I could say that was my cat, but I think my cat would be too lazy to, use the calculator or even open up a book and then use the calculator, let alone go on top of the chair. But anyway, I kind of got the meme fever for this page, so I apologize about that. But anytime that we want to use the graphing calculator to graph an equation, we want the equation to be written so that y is isolated. Okay, so if your equation isn't solved for y, then that's your first step. Okay, the first step is to solve for y. And the reason for that is because one of the menus on the graphing calculator, the one where we input our equation, requires that your equation looks like y equals something. So our equation doesn't have y solved for, so let's go ahead and take care of that, and we can move on to step 2. So to start solving for y, I'm going to move the 6x over to the right-hand side. It leaves behind negative 5y on the left. And on the right, because we're moving it across the equal sign, the 6x will turn into a negative 6x, which I'm going to write in front of that positive 73. What's the next step to get y by itself? Divide by negative 5, yep. So to do that, we'll divide the left-hand side by negative 5, and on the right, we'll divide each term by negative 5. And let me see if I can squeeze this in here. So y would be isolated with the first term on the right-hand side, negative 6 over negative 5. The negatives cancel, and I'm going to write that as 6 over 5 in front of x. And then positive 73 divided by negative 5 is really going to turn that addition to subtraction. And 73 over 5 doesn't break down, so we'll just leave it as 73 over 5. So this is what the calculator would prefer versus the original version of the equation. And it's this right-hand side that we'll type into one of our calculator menus. So let me pull up my graphing calculator. All right, gonna fire this up by pressing the on button. And to get this equation entered into the graphing calculator, you want to go up to the very top row and press the first button. Okay, so that takes you to the menu that is pictured on the first page of the notes. And You can see there are lots of different equations that could be typed in simultaneously. All right, and the more expressions that you enter for these y subscripts, the more graphs you'd be seeing in your coordinate plane. The most that we use in this course is just y1 and y2, so just a heads up. But to get 6 over 5 in the calculator, we'll obviously press the 6 key. There is no like fraction bar button, but you can get a fraction bar in there. It'll be slanted by pressing the divide button, which is right here. Okay, puts a slanted fraction bar. And then of course we want 5 in the denominator. Your variable x should be right next to this alpha key in the third row down, second column. Okay, there are other variable letters on there as well. We won't need to worry about those in this class. We'll just be using x. Yep, being recorded. So we'll press that. No problem. Now we want to subtract 73 over 5. I want to point out that there are 2 minus buttons on the calculator. There's the literal subtraction, okay, so if you just want to do something like 10 minus 5. But there's also this button at the very bottom, and this button is intended to make whatever's typed into the calculator negative. So if you wanted like -5 plus 18, if you want something to be negative, you would press this button first and then type in your number. All right. But with the way our equation is, we're taking 6 over 5x and subtracting 73 over 5. So we want to use the subtraction minus sign. So we'll press that. All right. This is usually bigger than the minus sign at the bottom. So sometimes you'll hear me say big minus sign or small minus sign. But now 73 over 5. So we'll press 7 and 3. And the slanted fraction bar is the divide button. And we'll type in 5. So to get the graphing calculator to graph this equation, you're going to go to the very last button in the top row where it says graph. And this is what I'm seeing. Okay. Is anybody seeing something different or getting an error? Anybody running into issues with this? Seeing different? Okay. So, Timothy, are you just seeing a different graph, or are you getting like an error message?
I'm just like a line, like just like the Y and X axis and like nothing.
Okay. Then don't worry about that. Once we move on to something called the standard viewing window, you'll be able to see the same graph as I am. All right, so hang tight. Now, going back to the notes, here's where one of my revisions should have taken place. Well, let me write the equation down first in here. So we typed in 6 over 5x minus 73 over 5. And I had a different equation while I was making these notes, in which case when we pressed graph, depending on our window settings, we might not be able to see it. So in other words, as my wife would say, this meme no longer applies. And I'm like, dang it, I really like it though. But anyway, I'm sure a lot of us saw the graph this way. If you didn't, then it's because of your window settings. Okay. Now, when we graph an equation with the calculator, we want to see some key features of it. Okay. We want to see kind of like the general shape of the curve. In this case, it's a line, so there's no curve to it really. But some graphs will have like hills and valleys, in which case there's some high and low points. So if we get a graph that we suspect has high or low points, we want to be able to see those. And we would also like to see where a graph is crossing both axes, if it is. Now currently with our graph, we can get a sense that it's the graph of a line, which is cool. it's not really going to have a hill or a valley, okay? Otherwise it'd be curved. But it does appear as though the line might cross both the x-axis and the y-axis. But we're not really able to see where that line is crossing the axes. So we're going to have to adjust something called a viewing window. Now, a viewing window, it's a section of the coordinate plane that's being displayed on your graphing utility. So, oops. This section of the coordinate plane, this isn't the entire coordinate plane, right? Both axes extend indefinitely, but this section that we're seeing of the coordinate plane would be considered the viewing window. And we're seeing some tick marks along the x-axis and the y-axis. And these, there are some tick marks that have some special terminology. The tick mark that's furthest to the left on the screen, so this tick mark right here is referred to x min. That's a value that we can adjust. The tick mark on the opposite side, very far end of this part of the x-axis, that's the x max tick mark. XSCL stands for the x-axis scaling, and that basically tells you how many units each tick mark is worth. The Y min is the very bottom tick mark on the y-axis, and the Y max is the very top tick mark on the y-axis. And the YSCL stands for y-axis scaling, and that's very much like XSCL. It tells you how many units each tick mark is worth. Now, with the viewing window that I have on the screen, and probably a good majority of us have, is referred to as the standard viewing window. And so, Timothy, if you want to get the same looking graph as I have, and if anybody else has a different looking viewing window than I have, then it's real quick and easy to get to that viewing window that I have by pressing zoom. Okay, so you can go ahead and press zoom. And if you look at option 6, it says Z standard, short for zoom standard. And you can scroll down to option 6 and press enter, or you can simply press the 6 key on the calculator. So either way you do it, the graphing calculator will redraw your equation, and it'll adjust the x min, x max, y min, y max, and the scaling according to these values. Got it. Yep. So to see what the x min, x max, and y min, y max, and so on and so forth are, you can press the window button. And as soon as you do zoom 6, the calculator adjusts all these values to the following: the minimum the minimum tick mark. All right, the tick mark furthest to the left is -10. That's its value. The tick mark furthest to the right on the x-axis is 10, and it goes by ones along the x-axis. And then the y min, y max, and y scaling is the same. The very bottom tick mark on the screen has a value of -10. The very top tick mark has a value of +10, and the y-axis is going by ones. All right. Everything good so far, folks? So, with that, just want to remind you what we're looking for when we graph an equation on the graphing calculator. We want to see where the graph intersects the x-axis or the y-axis. In some cases, it might intersect one and not the other. We also want to find high points, think top of a hill, and low points, think bottom of a valley. Now, we won't have that on our graph because it's a line. And even if we did have a graph where there are high and low points, we actually won't be learning how to find those until chapter 3. So in this section, we'll actually really just be focusing on where the graph intersects the x or the y-axis. Now, that brings up a really important concept in this course, or actually really important points on a graph, which is important in this course, and those points are known as intercepts. And intercepts, and we'll be doing more of a discussion on this later on, intercepts are points on the graph, or points where the graph crosses or touches the x-axis or the y-axis. Okay, so we look at the x-axis and the y-axis. If there's any part of the graph that's crossing or touching those axes, those are considered to be intercepts. So here's a diagram that I have from our textbook, which points out where the intercepts of this graph would be. Where the graph is crossing the y-axis, this point right here, that would be an intercept. But because it's crossing the y-axis, we could further classify it as a y-intercept, which I usually just indicate by y-int. We've got some points where the graph is crossing or touching the x-axis. We've got a point here on the negative part of the x-axis, and we've got a couple of points on the positive part of the x-axis. Regardless of where it's cross-touching on the x-axis, those would be intercepts, because that's where the graph is intersecting the x-axis. And I usually indicate those by x-int. All right, so we'll take care of the note right here, and then we will take a break, and we'll pick on up with the rest of this. So I do want to mention the format of either of these intercepts, the first being the format of a y-intercept. Now, y-intercept is a point at which the graph crosses the y-axis. Can anybody tell me what the x-coordinate of a point on the y-axis is? So like if I wanted to plot a point on the y-axis, do I go left or right before I go up or down? What would the x-coordinate be for a point on the y-axis? So this guy right here. Yep, it would be 0, and then whatever tick mark the graph is crossing it on the y-axis. So I'll put 0y, just to be general. So yeah, with any y-intercept, the x-coordinate is 0. That's because to plot the point, you just go up or down. You don't go left or right any. For an x-intercept, the roles change. The graph will be crossing at some point on the x-axis, so there will be an x-coordinate. But to plot a point on the x-axis, you don't go up or down any, so the y-coordinate would automatically be 0. Make sense? Okay, any questions before the break? All right, I'll see you guys in about 5 minutes or so. We'll do a little bit more with intercepts, and then we'll get back to graphing calculator stuff. Okay, so see you soon. All right, you guys ready to rock and roll? Let's knock out the rest of this note packet here. Woo! All right. So before we return to the graphing calculator, just want to do a quick example of finding the intercepts of a graph with the graph already provided. I'll make a little workspace for the X-Intercepts, and then a little workspace for the Y-Intercepts. Let's start with, I'll go with the Y-Intercepts. So let's look at the Y-axis. Is this graph crossing the Y-axis at all? Or in other words, does this graph have a point on the Y-axis? Yeah, definitely. It appears to be right here. Yep, and the ordered pair for that, first of all, to Y-intercept. The ordered pair appears to be 0, -2. And it looks like that's the only point on the Y-axis. Let's look at the X-axis now. It appears as though the graph is crossing the X-axis how many times? Yeah, 3 times, yep. So there are 3 X-intercepts. We have one here. Location of that point appears to be -7, 0. So, oops. I'll put that over here in my little list. Anybody want to offer the ordered pair of that point? One, 0, got it. And our third and final X-intercept, 6, 0, you got it. Not too difficult, right? Just look to see where the graph is crossing either axis, and depending on which axis it is, it's either going to be an X-intercept or a Y-intercept, and just label the points, write them out, and that's really how you do a problem like this. Now, I do want to make a little side note here. In my math lab, for intercepts, they might just ask you to provide the x coordinate of the x-intercepts and just the y coordinate of the y-intercepts. So they might have like x equals set up with a little blank box, and they might just have you type in like -7, 1, 6. And for like a y-intercept, it might be set up the same way, where you just type in -2. So both are valid ways of indicating intercepts. The author tends to just list out the x coordinates, which is legit. I think it's probably his preference. I really prefer to use coordinates though, because I think it's more beneficial to our learning. It reminds us of a lot of other important things with regards to points on the graph. But just wanted to give you a heads up on that. So back to our equation that we graphed on the graphing calculator. Okay, let me pull that up on the screen here. So one of the issues with the standard viewing window is that we can't really see the graph crossing either axis. If we want to see that, then we have to adjust some of the window settings. Now, before we do that, I want to show you how to access a table of values in the graphing calculator, because it can be beneficial when defining your window settings. We kind of get an idea of what the y values are doing and what the x values are doing, and based on those values, they can help us to define our x min, x max, and so on and so forth. To access a table of values in the graphing calculator, you're going to press this button, which is the second key. So you hit that, brings up a little up arrow on your screen. And this is indicating that you're about to access whatever is written above a button on your calculator. Okay. The button that we're going to press is the graph button, but because we pressed the second button prior to this, we're really accessing a table. Okay, so it's second and then hit the graph key, and here's a table of values. Now, we can actually figure out what the y-intercept is based on this information right here. It appears as though when x is 0, y is negative 14.6. Okay, but the fact that this y value is negative 14.6 probably means that we should define a y min value that's a little bit smaller than that. Okay, for instance, you can go up in the table and start seeing some negative x values, and you can see that these y values tend to get more and more negative. All right, so to give us a cushion, I think what I'd like us to do is define our y min as negative 20. Let me go to the screen here. So where it says y min, we'll enter this in just a second, but I just want to log it down. Y min will be negative 20. Now, as for y max, I'm going to kind of base this on the X-Intercept. And the X-Intercept will also help us base our X max as well. So what I'm going to do is show you that as you increase the value of x going into the positive now, you'll see that there's a change in sign in the y values eventually. And it appears to happen between 12 and 13. When x is 12, we have a negative y value, and when x is 13, we have a positive y value. So this is an indication that there's going to be an X-intercept perhaps between 12 and 13. So to give us some cushion, I think what I'd like to do is maybe define an X max value of 15, just so that we can see the graph going through the x-axis. So going back to our notes here, I think an X max value of 15 will suffice. Now an X min of negative 5 is probably good enough because it'll give us a good viewing window in a way that we can see the graph crossing the y-axis and go a little bit further beyond that. Now, the scaling on the x-axis, I might recommend going by 5s, since really between negative 5 and 15, that's 20. And if you left your x scale as 1, your graphing calculator is going to try to fit 20 tick marks on the x-axis, which could make it look a little busy. So if you want less tick marks, you can increase your x scale value, and I would maybe go by 5s for this example. It's actually okay to leave y max at 10. That'll definitely give us enough cushion to see the graph crossing the axes. Now on the y-axis, we're going from negative 20 to positive 10, so that would require 30 tick marks on the y-axis. So if your y scale is 1, that'll give you 30 tick marks, and your y-axis will look pretty thick, and it can kind of be a little bit of a distraction. So what I would recommend going by on the y-axis, maybe going by 5s as well. All right. So in our graphing calculator, let's press the window key, and we'll adjust these settings. All right. X min we want to be negative 5, and you can actually just overwrite these numbers by typing in the numbers right off the bat. And because we want 5 negative, we're going to want to press the small minus sign at the bottom. We'll press the small minus sign and then 5. we'll jump down to X max. We'll change that to 15. And the x-axis is going to go by 5s. The minimum y value that we decided on is -20. So small minus sign, then 20. We can leave y max at 10, but we'll go by 5s on the y-axis as well. And once you've adjusted your window settings, you can press the graph key. You guys seeing that? All right, anybody getting something different? Okay, I'm gonna go back to the notes. And this is probably where one of my edits should have been as well. I thought I could maybe fudge, this screen clipping with our window settings, but I think it's just gonna maybe confuse things. So we won't use that viewing window that I have right here on the page. Instead, we'll just kind of sketch it out on our own. I'll draw a y-axis and an x-axis. And what I'd like to do is indicate some of these window setting values. For example, x min is -5. So I'll put a tick mark on the negative part of the x-axis for -5. And our x max value is 15. So I'll go to the far right and put a tick mark of 15. Our minimum y value is -20. So near the bottom of the y-axis, I'll put -20. And our y max value is 10. So at the very top of the y-axis, I'll put a tick mark and mark it at 10. And then I'll sketch what we were seeing on the graphing calculator screen. Our graph kind of did that. And in some cases, what I do is I just kind of give this graph a name. We entered it into Y1, so I'll just indicate that this is our graph from Y1. So can you see the intercepts now? Can you see where the graph, or can you see that the graph is crossing both the X and Y axes? That's what we wanted to do, right? We wanted to see those key features. So what we'll do next is actually use the calculator to tell us where those 2 points are at, okay? We have a y-intercept appearing to be on the negative part of the y-axis and an x-intercept. And the graphing calculator can actually be used to tell us where these are approximately at. So on the next page, I have some step-by-step instructions on how you can find these intercepts. Again, we're going to forego these viewing window screen clippings here. We'll just draw out the graph again ourselves. And since we've already written down what our window settings are, we drew them on the last coordinate plane. I'm not really going to be picky about labeling those tick marks again for this part, but I will include a little sketch of the graph. For this part, we're going to find a y-intercept. Okay, so in other words, we're going to try to figure out where that point is at on the y-axis. So we'll do a live demonstration of it, of course, but the step-by-step instructions are here. So if you need to, refresh yourself on how to do it, I've got those instructions typed out for you here, or you can always watch the recording or ask me questions. But I'll go ahead and pull up my graphing calculator. And we want to get to a certain calculator menu, and that calculator menu is this one right here, calc, short for calculate. And because it's written out above the trace key, we have to press the second key before press the trace key. So second, trace. And for a y-intercept, you're going to use option 1, okay, value. And basically what this program does is that it allows you to type in an x value between your x min and x max, and the calculator will spit out the y value that corresponds to it. So second trace, and we're going to select option 1. So since 1 is already highlighted for us, we'll press enter. Kind of fat fingering things here. Let's see. Here we go. Okay. So we'll press enter. And at the very bottom of your screen, you're being requested, or an X value is being requested. And remember, for a Y-intercept, the X value is always 0. So we'll type in 0 and press enter. And what that does is it tells you what equation it's finding the Y value for. It indicates the X value you typed in, and to the right of that, it tells you what the corresponding Y value is. And it also puts a cursor right at the Y-intercept. Okay, so for purposes of what we need, this is the value we want, negative 14.6. Are you guys getting negative 14.6 as well? Sweet. Okay. So what I usually do is I draw a little squiggly arrow pointing to the intercept, and then near it, I'll write out the ordered pair, 0, comma, negative 14.6. Okay, that's our Y-intercept. Finding an X-intercept is a little bit more involved, but we tend to get more practice with it than finding the Y-intercept because it's one of the skills that we use for solving equations. So I'm going to sketch out our graph again. It's Y1. This time, we want the calculator to help us find this point, which is an X-intercept. So let me go back to my calculator and show you how you can do that. We actually want to go back to this calculate menu. So we'll press second trace. And this time we're going to use option 2 where it says 0. Okay, so select option 2. And you'll notice that your cursor is blinking on the Y-intercept. And underneath it, it's asking you a question. It wants you to define a left bound. Now, this is something you'll always have to do when finding X-intercepts. You'll have to define a left bound and a right bound. And the reason for that is because some graphs have more than one X-intercept, and so the calculator needs to know which one to focus on. But a left bound is going to be a spot on this graph that's a little to the left of the X-intercept. So here's our X-intercept, somewhere right here. A left bound would, a good choice of left bound would be, somewhere right here on the graph. And what we'll do is we'll move this blinking cursor until we get to around this area of the graph, and then we'll press enter. Okay, and to move the blinking cursor over to that area, we'll hit the right arrow key until we've landed in a spot that we're good with. And this would be a good left bound. It's to the left of where the graph is crossing the x-axis. And once you're satisfied with where your cursor is at, you can go ahead and press enter. And you'll notice at the bottom of your screen it's asking for a right bound. So now we need to move the blinking cursor to an area that's to the right of the x-intercept. So we should probably move it somewhere right here. Okay, so we'll continue moving this along the graph until we're to the right of the x-intercept. Maybe somewhere right here is good. Okay, that's to the right of the x-intercept. So once you're good with your right bound where your cursor is at, you can press enter. And now you get a third and final question here where it wants you to guess. And basically what this means is it wants you to move the blinking cursor a little bit closer to the x-intercept. Okay, so I'm now going to travel a little bit backwards until I get to where I'm a little bit close to the x-intercept. And we can press enter. And what happens is that it puts your blinking cursor directly onto the X-intercept, and it spits out the values at the bottom of the calculator. It says 0, which we'll learn why it's called the 0, in addition to an X-intercept later on in the course. And it tells you that the X, the value of the tick mark where this intercept is at roughly 12.17, if you want to round, comma 0. Okay? Which, by the way, if you get a value like this, where it's got a lot of digits past the decimal point, the rule of thumb is just to round to 2 decimal places. All right, but before I write this down on the notes, did anybody run into issues with finding this? Okay, Sarah, what's your calculator saying?
For some reason before I was able to get change my window settings, but every time now when I try to change it to the new settings that we decided on, it says error.
Okay, so go ahead and press the window key.
Okay.
And can you tell me what your X-min is?
I'm able to change it to -5, but then when I try to go press down to go to X max, it says error.
Okay, did you use the small minus sign in front of 5?
I probably didn't. Ah, thank you.
Okay, check your -20 as well, just to be on the safe side. So do you have the small minus sign in front of 20 as well?
Yeah, 1 second.
Okay.
Okay, I got it now. Thank you.
No problem. All right, so to recap, the second trace, option 2. Left bound is an area of the graph that's to the left of the X-intercept. Press enter. Right bound, area on the graph that's to the right of the X-intercept, which forces us to go on the other side of the X-axis. Press enter, and then move your blinking cursor near the X-intercept. Press enter, and there it is, 12.17-ish, comma 0. So Sarah, let me know if you get those values, and we'll move on. Sweet. All right, anybody else getting something different or an error message or anything before we continue? Alrighty. So on the notes, I'll just indicate that this is at roughly 12.17, comma 0. All right, and that's it for the section 1.1 stuff. We're now going to move on to the 1.2 graphing calculator stuff. And this is where we'll use the graphing calculator to help us solve equations. All right, the other part of section 1.2 involves equations as well, but those are going to be equations that we can solve with algebra, so we can solve those by hand. But knowing how to solve equations with the graphing calculator beforehand gives us a way of checking our answers when we go to solve them by hand. And there are 2 features of the graphing calculator that you can use to solve equations. I do have a little bit of wisdom as to which one you would use over the other, and that's really based upon how the equation is written. But the 2 features the calculator has which help us solve equations are known as the intersect and the zero features. And on this page, I have step-by-step instructions on how you would do each of these, just for your reference. But we'll obviously do it together live here today. All right. I do want to talk a little bit about some of the stuff that leads up to each of these tables. Let's start with the intersect feature. For the intersect feature, you opt to use this one if the expression, if you have expressions on either side of the equal sign. So in other words, if, you know, on the left of the equal sign is an expression in x, and on the right-hand side of the equal sign is an expression in x, that's when you probably want to use the intersect feature. And the intersect feature basically is a process in which we find points of intersection, which is why it's called the intersect feature. And it requires two equations. All right, so we take one side of the equation, define that as our y1, and we take the other side of the equation and define that as y2. And when those graphs are plotted together on our calculator, we look for any points where they might be crossing each other. All right, and then there's some steps we can take to help us find out exactly where they're crossing. The zero feature is used when your equation is set equal to 0, in which case this doesn't require two equations. There's just going to be one equation that we type in, and the points that serve as our solution using the zero feature are going to be the x-intercepts of the graph. All right, which we just had you know, exposure to with that line graph on the last page. All right, so with intersect feature, you find points of intersection. With the zero feature, you just find the x-intercepts. So without further ado, I'll show you how to do that. So it says here, use a graphing utility to approximate the real solutions, if any. Some of these instructions are pretty wordy in my opinion. Rounded to 2 decimal places. Now, the first hurdle is deciding which feature to use. Okay, you'll notice that this equation is not set equal to 0. Okay, so you probably don't want to use the zero feature. In fact, it looks like we have an expression set equal to an expression. Okay, one expression is x cubed minus 6x, and the other expression is simply 2. And what that's going to do for us is it's going to help us define two equations. Now, what I usually do is I use the expression on the left-hand side as my definition of y1, and I use the expression on the right-hand side as my definition of y2. Okay, so just to recap, we're going to use the intersect feature. And when we get to the graphing calculator, we'll go into the y equals menu, and in y1, we're going to type in x cubed minus 6x, and in y2, we're going to type in 2. Okay, you ready? All right, so let's press y equals. To get rid of our last example, you can just press clear, which is right underneath the arrow buttons here. And to type in x cubed, you're going to press the variable x key. And then to get the power of 3, you're going to hit what's called the caret button. And you know what? I really don't care at all for that name. But anyway, if you press this, with my version of the graphing calculator, it puts me in the exponent of x. With other calculators, you might see the caret symbol right next to x, which is fine. Either way you do it, we want to press 3. And if you're still in the exponent like I am, you're going to arrow over to the right to get back down on the ground. And from this, we want to subtract 6x. Let's hit the down arrow button where we're in the row for y2, and we'll press the number 2. Now, I want to see these graphs in the standard viewing window. Okay, so we're going to go back to the standard viewing window settings. Okay, what's up, Timothy?
The caret key for the cubed, which I lost track. Was that the button that's by a tangent, or?
Yep.
All right, so x, and then 3. All right, it just kind of looks different on my calculator. Like, it doesn't look like x cubed like on like yours.
Does it look like?
Yes. Yes.
Yeah, that's okay. Yep. You
Okay.
could leave that typed in as is and then subtract 6x.
Okay. I'm sorry.
No, that's okay. No, I'm glad you asked that because it is kind of a big deal for sure. So you should be good for that graph. So for the exam, I don't usually provide those instructions. Usually what happens is we've gotten enough practice in to where it kind of will become like second nature. So I usually don't provide those instructions. I'm really not supposed to be honest with you. But Kyle, I'm sure we'll have enough practice in there to where you won't need to worry about having the instructions. All right. All right, now let's press the zoom key. And we want the standard viewing window just to see what happens. And if it turns out that we can't see any points of intersection in the standard viewing window, then we'll adjust our window settings as necessary. All right, so zoom, and I'm just going to press the 6 key. And here comes the graph of Y1, and there's the graph of Y2. All right, you guys getting the same graphs? All right. So I hate to flip back and forth so much on you, but I do want to log some of this down before I forget. Okay, Y1 did something like this. We'll label that as Y1, and then Y2 appeared to be a horizontal line. And these graphs appear to be intersecting each other. How many times? Yeah, 3 times. We got a point of intersection at that spot, another one at that spot, and then another point of intersection, which appears to be in quadrant 1. So we'll actually do 3 rounds of the intersect feature. You got to do each one individually. And I usually go in order from left to right. So the first point of intersection I'll have us find is this one. Okay. And to do that, you're going to press second trace. Okay, it takes you to that menu that we were using from earlier. And it's option 5 where it says intersect. That will help us find the points of intersection. All right, so go down to option 5, press enter. And you do get a series of questions at the bottom of your screen, but with the intersect feature, you can kind of shortcut this a little bit by simply moving your blinking cursor to the point of intersection you want to find, which is right around here, and then just pressing enter 3 times. So to repeat, we're going to move this blinking cursor over to this area of the graph, and we probably need to hit the left arrow key a few times to do that. Okay, well, a lot of cases you don't land right on top of it, but close enough is good enough. So get your blinking cursor around this area on the graph, and we just press enter 3 times in a row. Okay, so once it's there, press enter 1, 2, 3 times, and in a matter of no time, it tells you the approximate coordinates of this point of intersection. So can I get confirmation on an x value of roughly negative 2.26, comma 2? Sweet. Okay. Let's find the next point of intersection, and we'll have to repeat this process over, starting with second trace, and we'll choose option 5. And we're going to move the blinking cursor to the right now so that we can get on this part of the graph. All right, so it's a little pixelated. This isn't Xbox One graphics. This is more like NES graphics on the calculator, but hopefully you can see your blinking cursor somewhere near that second point of intersection. Now you press enter 3 times. And can I get confirmation on an X value of roughly negative 0.34, comma 2? All right. Let me have you guys go ahead and find the third and final point of intersection. Okay, so start with second trace and then go from there. Yep, that's right. .60-ish, comma 2. Way to go, guys. I'm so proud of you. You're going to make a math teacher cry. All right, let me just label these points. That was roughly negative 2.26, comma 2. We had roughly negative 0.34, comma 2. And then, yep, 2.60, comma 2. Now, in terms of solutions to the equation, those are always going to be the x-coordinates. So since there are 3 points of intersection, this equation has 3 solutions. And here's where I'm going to write out the solutions, just kind of all in a row. I'll say x is approximately, since we rounded most of these values, negative 2.26, comma, negative 0.34, comma, 2.60. Or you could separate them out and just say x is approximately negative 2.26, x is approximately negative 0.34. I'm okay either way. All right. So let's work on the next example. Same instructions and very, very similar looking stuff as with the last example, but there's one key difference. What are you guys noticing about the format of this equation? Yeah, we actually have an equation that's set equal to 0, don't we? So because one side of the equation is 0, we're going to use the 0 feature. Now the 0 feature only requires one equation entered into the graphing calculator. And that one equation is going to be the expression that's on the left-hand side. This is what we're going to type into y1. Okay, so I'll indicate that below. y1 is going to be x cubed minus 6x minus 2. Let's go to the graphing calculator. Type that in. I'll just clear both of these out and start from scratch. X, caret key 3, big minus sign, 6x, big minus sign again, 2. I'll hit zoom 6. Okay, let me know if you're getting the same graph or if you're getting something different. This good? All right. So I'm going to sketch this out. Our coordinate plane here did something like that. And remember, with the 0 feature, what you want to do is find the x-intercepts. And this graph appears to have 3 x-intercepts. Now, I'll tell you a secret. this equation is actually a rewrite of the equation that we just solved. So there's a reason why I did that, and you'll see once we find the x-intercepts, okay? But our equation from the last time had 3 solutions, and we should expect there to be 3 solutions with this equation as well, since it's just a rewrite. And you'll notice that on this graph that we have 3 x-intercepts. And each of these x-intercepts is going to be a solution to this equation. Now, we'll have to use the zero feature to find each of them. And, with each x-intercept, we have to, repeat the process. And I usually go in order from left to right. So the first x-intercept I'll find along with you is this one. And we'll go to the graphing calculator. And for the zero feature, you hit second trace, and you select option 2. Now here we do have questions that we have to answer. The first question is where our left bound is going to be. Now keep in mind, this is the x-intercept that we want to find. So a left bound is going to be a section on the graph that's to the left of this point. So probably somewhere right here is where we should move our blinking cursor for a left bound. Okay. Another way of saying or verifying this is the left bound is that if you were to look directly at the x-axis from this point, you would be to the left of the x-intercept. Okay. We'll press enter, and now for a right bound, we want to go to a point of the graph or a section of the graph that's to the right of the x-intercept, which will force us to probably go up here somewhere. Okay, so this would be a good right bound because it's to the right of the x-intercept. We press enter. And now that third and final question is a guess, where we just want to move this a little bit closer to the x-intercept as best as we can. And press enter. And can I get confirmation on negative 2.26-ish, comma 0? You guys are rock stars. This is awesome. All right, so I'm going to mark this up a little bit more than my intersect graph. And that's just to indicate where we define the left bound and the right bound. Our left bound was somewhere right here on the graph. I'll indicate that with LB, and there's my cursor. And then right bound was somewhere around right here on the graph, which I'll indicate by RB. And that allowed us to find the x-intercept, which has an approximate value of negative 2.26, comma 0. Now, what do you notice about the x-coordinate here when compared to our last example? Isn't this one of the solutions to, yeah, exactly. So we actually should see a repeat of all those x values that we found with the intersect feature. So I'm going to do this one along with you, and then once we're done with that, I'll have you give the last x-intercept a shot, and then it'll be time to finish up class. Now with the last 2 examples of this section, I plan on doing solution videos. So what I would do with the last 2 examples is maybe see if you can work them out on your own, and you can refer to the solution videos that I'll be uploading to check your work. All right, but let's finish class up by finding those last 2 x-intercepts. So we'll start over with second trace, option 2. Now it's this x-intercept that we want to find, and for a left bound, we might want to move our blinking cursor on this area of the graph. It's closer to that x-intercept, but still to the left of it. So this would be a good left bound. We can press enter. And then a right bound should be somewhere maybe right here on the graph. It's close to the x-intercept and a little bit to the right of it, which is what we want. And press enter. And then for your guess, let's just move the blinking cursor a little bit closer to the x-intercept. Press enter. And confirmation on negative 0.34, comma 0. Sweet. All right, guys, well, your mission, should you choose to accept it, is to find the ordered pair of the last X-intercept. Yep. Very good. Probably no surprises there, right? Because like I said, I kind of spoiled it. We should get the same X values as our last example. All right, so let me just mark up this graph a little bit. So for the second X-intercept, this is where the left bound went this time. The right bound went underneath the X-axis. And that gave us an approximate value of negative 0.34, 0. Now for that last X-intercept, perhaps you put your left bound somewhere near here on the graph, and your right bound somewhere near here on the graph. Oh, my pen pooped out on me. Let's see if I can use my backup. Give me just 1 second. Okay, right bound. And as you guys indicated, that's at approximately 2.60, 0. So again, our solutions are going to be all the X coordinates of these points. And I'll just jot them down underneath the graph. And do you guys have any questions for me before I let you go?